to P, which is November to Papa, which is a required track of 315. So planned track is 315. You find your position is 40 nautical mile outbound and 6 nautical mile to the left hand side of the planned track. What is your track made good? So N to P. Okay. So let's join that, and then let's say this is your point N. So now outbound from N. So the distance that you have traveled from N is 40 nautical miles. So 40. And distance of track is 6 nautical miles. Distance of track is 6 nautical miles. And you have to find your track error. So let's label this. You have November Papa route, which is your planned track. This is your planned track, right? November to Mike is your track made good. Is your track made good. And now you have to find track error. So let's first find track error angle. So track error angle is distance of track divided by distance gone into 60. So distance of track, what is distance of track? It is 6 nautical miles. It is 6 nautical mile. What is distance gone? Distance gone is 40 nautical miles. Distance gone is 40 nautical miles. So the total answer will be 9 degrees. So track error angle will be 9 degree to the left hand side. So 9 degree left or port. 9 degree left or port. Okay. So distance of track is 6. Distance gone is 40 into 60. When you do all the calculation, you get 9 degree. Now your planned track direction is 315 degree. Your planned track direction is 315 degree. And now your track made good is to the left hand side, of planned track. So when you go to left hand side, or when you move or fly anti-clockwise, the directions decrease in value. So if planned track is 315 degree and track error is 9 degree to the left hand side, so your track made good will be equal to 315 minus 9, which is equal to 315 minus 9 is 306 degrees. So track made good will be 306 degrees. Okay, track made good will be 306 degree, which is 315 minus 9 degree, 306 degrees. Next sum. So there is 660 meters. So this surveyor places himself 660 meters from a mast and measures an elevation angle 4 degree to the top of it. What is the height of the mast? So this is a trigonometry sum. So let's draw the diagram. Okay, so this is where your observer is located on the ground, and this is the top of the mast. Okay, so the distance from the mast and the observer is 660 meter, and the elevation angle is 4 degrees. Elevation angle is 4 degree. We have to find the height of the mast, the total height of the mast. So let's use this tan formula. Using tan formula, tan theta is opposite side of the triangle divided by adjacent side. Now theta is 4 degrees, so tan 4 Opposite side. So opposite side of 4 degree is this height, which we have to find out. So height. Adjacent side of the triangle is adjacent side to the angle 4 degree is 660 meters. So 660. So your height will be 660 into tan 4 into tan 4. So height equals to 660 into tan of 4. So tan 4 degree using your scientific calculator will be 0.069. So 0.06. So 660 multiplied by 660 is 46.15. So height is 46.15 meter. Okay. So using tan theta formula, you can find this out. Let's find the answer using 1 in 60 rule. Let's find the answer using 1 in 60 rule. So 1 in 60 rule states the angle, the track error angle equals to distance of track divided by distance gone into 60. Distance of track by distance gone into 60. So what is the angle? Angle is 4 degree. Distance of track. So this is your distance of track. So if this is your planned track, okay, let's say this is your planned track. So this will be your distance of track, okay, away deviated from the planned track. So distance of track. Distance of track, I don't know. So what is your distance of track? It is nothing but your height of the mast. So let's write it height. Distance gone. Distance gone is nothing but your planned track, which is 660 meter into 60. So height will be equal to 4 into 660 divided by 60. So height will be equal to how much? So 44 meters. So if you solve this sum using tan formula, you get 46 meter. And if you solve the same sum using 1 in 60 rule formula, you get the answer as 44 meter. So not much difference, but I have shown you both the ways. So whichever way you are comfortable with, you can solve that sum. And in exam, choose the option which is closest to the option that you have or to the solution. Next question. You are flying an instrument approach to an airport and the required glide slope is 3 degrees. What height should you be passing when you are 2 nautical miles from the touchdown zone of the runway? And here they have given 1 nautical mile equals to 6,000 feet. So simple. Draw the runway, and from the runway, that is touchdown zone of the runway, you're 2 miles away. Okay. And you are at a particular height. And the glide slope angle is 3 degree. So we will use 1 in 60 rule formula to calculate the height of aircraft. So angle equals to distance of track divided by distance gone into 60. Substitute the values. Angle is 3 degree. Distance of track, which is your height, you don't know. You have to calculate that. So write height. Distance gone is 2 nautical miles, the distance away from the runway, into 60. Cross multiply. And when you cross multiply, you have to convert this 2 nautical miles into corresponding feet, because all the height of aircraft or height of any other obstacle is always measured in terms of feet. Okay, so convert nautical mile into corresponding feet. 1 nautical mile is 6,000 feet, so 2 nautical mile will be 2 into 6,000. Cross multiplication will give you a height of 600 feet. Okay, next. Similar question, you are flying an instrument approach to an airport and the glide angle is 2.5. You are on the glide slope and you are passing a height of 1000 feet QFE. So QFE is the atmospheric pressure existing at aerodrome or your airport, and all vertical distance is measured with altimeter setting QFE are heights. Okay, so height is 1000 feet, which is your 1000 feet above the aerodrome or airport. What is your range or what is your distance from the touchdown point? So in the previous question, you were given the distance from the runway and height was asked to be found out. And here in this question, you have been given height and told to find out range or distance from the runway. So same approach is the same. Draw the runway, glide angle 2.5 degree, height is 1000 feet. Okay, height of aircraft is 1000 feet. You have to calculate distance. So formula angle equals to distance of track by distance gone into 60. Substitute the values, you will get a total distance, that is distance from the runway, equal to 24,000 feet. Because your height was in terms of feet, so final answer is also 24,000 feet in terms of feet. Now when calculating distances on the ground, they are in terms of nautical miles. So convert this feet into nautical miles. Now one nautical mile is 6,000. So 24,000 will be how many nautical miles? Cross multiply. You get answer in 4 nautical miles. Over here, you're flying from Q to R, which is a required track of 125 degree. So QR is your planned track of 125 degree. You find that your position is 40 nautical mile from R. The question so far, okay, the questions we solved so far, we always had distances given from the departure point. Now in this question, we have been given a distance from the perspective, from the point of view of your destination. So you're 40 nautical miles from your destination R, okay, and 2 nautical miles to the left of the planned track. What track must you fly to arrive overhead R? To arrive overhead R. So from this location, what direction of flight will you fly to come directly overhead R? So before finding that direction, you will need to know this angle. We call it closing angle. Why closing angle? Because closing angle closes the error made between your original track or planned track, required track, and track made good. Okay, so closing angle when we solve using the formula, normal formula distance gone into 60, we get the answer as 3 degree. So I have drawn this triangle again, QR triangle. So QR was a distance gone, TQ your distance off track, closing angle 3 degree. Okay, now this forms an alternate angle, a set of alternate angles is always equal. So if this is 3, this will also be equal to 3 degree. Now I know my planned track, this is my planned track QR, and track is 125 degree. So I have drawn this line parallel to it. This will also be, since it is track, parallel to planned track, its direction will also be the same. So if this is 125, so that direction will also be 125 degrees. And now you have to find the direction that your aircraft must fly in order to come directly overhead, R, overhead R, right? So now, so the track made good will be equal to 125 degree. 125 degree will take you straight ahead, but you don't want to go straight ahead. You want to make a right turn. You will have to make a right turn towards R. And whenever you make a right turn or clockwise turns, your directions increase in value. So 125 degree plus 3 degree will be equal to 128 degree. 128 degree. So the direction of your new track, okay, to arrive overhead R will be equal to 128 degrees. Okay, so you will fly a direction of 128 degrees in order to arrive directly overhead R. Okay, so this is how you do this sum. True. So all directions will be true. Pay attention to that also. Next, you are flying from Sierra to Tango, which is a required track 272. you find that your position is 50 nautical miles from Tango, again 50 miles from destination Tango, and 5 miles to the right of it. What track must you fly to arrive overhead Tango? So Sierra to Tango is given. So you are 50 miles away from your destination and your distance off track is 5 nautical miles to the right. So I will draw this again here. This will be your closing angle since you want to arrive overhead your destination. So closing angle formula is distance of track divided by distance gone into 60. So distance of track is 5, distance gone is 50 into 60. So angle is closing angle is 6 degrees. Closing angle is 6 degrees. So let's read out this triangle over here. So if this is your 6 degree and the planned track direction is given 272 degree. It is 272 degree. See, 272 degree. So I'm drawing a line which is parallel to your planned track. So that direction will also be parallel to your planned track. So its direction will also be equal to 272 degrees. Okay. Now this angle is 6 degree. So if this angle is 6 degree, so this angle will also be equal to 6 degree. Alternate angles are equal angles. So now currently your aeroplane is flying here. Okay. And now in order to arrive overhead a destination, in order to arrive directly overhead destination, it will have to follow what direction? So the direction to fly will be equal to 272 minus. Why minus? Now from here we will have to make a left turn. We will have to make a left hand side turn, right? We will have to make a left hand side turn to arrive destination, to arrive at destination. So minus 6 degree. So the direction you will fly will be equal to 266 degrees. 266 degrees, that is true direction. Okay. So your planned track was 272 and therefore to arrive directly overhead your destination, you will have to make a left turn and therefore your new direction becomes 266 degrees. With this, we come to the end of this lecture. I hope you have understood all the questions and answers that we have done today. Also, you have understood the question answers we have done in the previous video. So do watch both these videos together. Practice this sums twice, thrice, multiple times till you feel confident in them. If you have liked this lecture, hit the like button, subscribe to this channel, and do share this video with all your friends. All the best. Keep learning.